How you guys all doing? So, how many of you here because this was the only session that wasn't talking about Azure and the cloud? So, when you go ahead and do the evaluations, I get, fives. I get the full score because I had the right content at the right level just because I didn't talk about Azure and the cloud. Okay, so I just want to make sure we got that covered. If you need help filling out the survey, just let me know. I can tell you exactly what all the answers are. No big deal. Okay, a question for you guys. How many of you are using Visual Studio 2010? Raise your hand. For production code. Wow, a vast majority. That is wonderful. That is excellent. Okay, good. My name is Mark Michaelis, and I run a company called IntelliTexture, and I've written several books and stuff like that. So I'm going to talk to you today about C#, and I'm trying to bring you through the gambit of what the features have been since the first release. I want to be clear when I say I do that. I encounter a lot of people that are using Visual Studio 2010, but they are not using the language and all the features that became available with Visual Studio 2010. And when I say that, I don't just mean the features that were available specifically with the most recent release, C# 4.0, but I mean the stuff that became available with C# 3.0, the stuff that became available with C# 2.0. Even things like generics, which for some people are inherently obvious, they got it, they use it every day, they can't imagine writing code without it. I repeatedly come across people that are not using that and don't really understand what the underpinnings of generics are. So we're going to go through bringing you forward from C# 1.0 all the way to C# 4.0 and go through just about every single feature in the language. That's a huge task. It normally takes me several days in classes when I do teaching, and we're going to try to put that into an hour and 15 minutes. This is Lucian. Lucian is going to be my code monkey. Is that the word I'm supposed to use? The technical term. He's actually a senior program manager on the languages team at Microsoft. So if anything goes wrong, if my demo doesn't work, anything doesn't work, he's the guy to blame. Okay, just so we got that well established. One more comment about the talk. If you have questions, I'm totally cool with that. Okay? I just asked you come in front of the mics and ask. It's great to have an interactive session, so I'm totally open to interacting and hearing your questions, and you ask them as we go. So feel free to do that. Just come up to a mic, I'll see you, and I'll call you out. That'd be great. Oh, I'm going the wrong way. So here's the gambit of what's become available in the language. You'll see there are some things that I've crossed out. Those are the sort of rare occurrence or not so frequently used parts of the language that we're not going to cover. This is done clockwise. We're going to start at 1 o'clock and we're going to go all the way around. Those are all the features that we're going to cover, and a few of them have been crossed out, and they're sort of nuances or things that are not so critical. But the rest of it we should be able to cover in the amount of time we have. That said, to do this effectively, I'm going to go fast. Okay? So I'm going to go fast. There's a lot of content. Obviously, this is a huge scope for a talk that's only an hour and 15 minutes. I'm choosing that intentionally. What I'm basically saying is it is better for me to give you all the material and allow you to grok it and know that it exists. And then afterwards, you can watch the streaming or you can go back and review it, rather than covering a smaller amount of material, but covering in so much detail that you've just got that content. So I'm choosing to be broad and fast rather than covering less content and going really deep. Okay? That said, I will do things like talk about IL and how the compiler works and things like that. So we'll get into some fair depth, but it's just going to be fast. It's just going to be fast. Oh, I keep pushing the wrong direction. So put your seatbelts on. Why don't you go ahead and get us started here. So what we've got here is I've created a test project. I don't know how many of you are doing TDD, but we're going to basically do TDD. And I have a project set up. It only has about 4 files in them. And this is the key file we're going to work in. It's called Improving C#, and it's just a test file. So you notice the methods have an attribute on the top that says, this is a test method. And then we're going to go ahead and execute the test method. And what we're going to do is transform the code from a C# 1.0 code to a C# 4.0 code. Now, I was sort of reluctant about this. I would much prefer to start from scratch and just write it all. But in order to get this amount of content in, I'm going to go ahead and start with some code written. However, I think it's fairly simple. Everything's concise. You can just look at that little bit of code. I don't think there's any magic or something that you can't follow in terms of what we're going to cover. So to start, you'll notice that we have this pair. We've got a pair, and it basically collects 2 items. And we can go ahead and drill into that. And if you look at it, it's basically a pair. It's got a constructor, and then it's got 2 properties on it. Let's go ahead and change the properties on this. You'll notice here that when you declare a property in C# 1.0, we declare the field, And then after the field, we go ahead and put gets and sets. And starting with C# 2.0, we're able to delete all of that. And we're just able to type prop, tab, tab, and that'll give us IntelliSense. And here we can go ahead and type string and item1. And automatically, we got our first real trivial change to the language that is all important. I would say in general, if you're going to be writing a property and you don't require interception, some kind of validation, you should just go ahead and use a property. This I would use in place of my fields as well. If I'm going to write a field that I was going to, whether I was going to wrap it or not, I would always just start with the property. So if there's no interception, no kind of validation, just generate a property like this. It's easy to do. Next, while we're about this, let me show you one other feature that came out in C# 4.0, and that is optional parameters and named parameters. If you scroll up to the top of this file, back in the pair file, you'll notice that this takes, actually let's look at person. Would you mind switching to the person class? You'll notice in the person class, I take the first name and the last name, and I've gone ahead and put an age equals null. Okay? Ignore the question mark for a second. I've got age equals null here. The reason I'm doing that is I'm basically saying you can call this method, in this case is a constructor, you can call this method and you're not required to pass the age parameter, even though there is one. Okay? Even though there is one, you're not required to pass it. You can simply go and call this method, leave the age piece out, and it'll go automatically, by default, that value to null. This is a feature that was in high demand in C# 1.0. The Visual Basic crowd got it. That's the last time I'll say that word. But the Visual Basic crowd got it, and C# never had it. But it was added to the language. Anyone know why we added named and optional parameters to the language? COM, this is right. This is so you could program against Office more effectively. Right? That was the reason this was added. So that gives you two sort of introductory features. We'll just cover those quickly. Automatic implemented properties. Basically, I would use them anywhere where you don't have to have a backing field. It will generate the backing field for you. It still exists. There is a backing field. It just generates it. The compiler will generate it for you. That's what goes on. And then the optional name parameters. They basically reduce the need to overload. For a long time, I struggled and wrestled with, do you go ahead and use this rather than using overloading? And as I've coded more and more and spent more time in the compiler, I actually would advise you to say, it's actually better to go ahead and rely on optional parameters would be to continually overload your code all over the place. It just reduces clutter. It reduces how much code you have to maintain. So generally, my guideline to people is go ahead and use the optional parameters rather than overloading a method time and time again. Okay, let's go make some changes. Right here, we've got a test. And in this test, you'll notice that I've got a pair. And the pair takes, in the constructor, it takes two strings. And then we can go check the values of the strings. We've got item 1 there at the bottom. We can go and check the value. Let's go into verify pair right at the top there. In verify pair, you can see I'm going ahead and doing a pair.item1, a pair.item1. Now, this is great. This is exactly how I would write this class if the only thing I ever had to collect was strings. However, what happens when, hypothetically speaking, you actually want a pair that has something other than strings? Say, for example, a double. So what are the options for me to create a class that will handle a double versus a string? What do I have to do? There's two options for me. Assuming no generics, what are the two options I have? I can create a pair double, right, that specifically collects type double. And then when I want to do a float, I can create a pair float. And when I want to do a GUID, I can create a pair GUID for every single data type that I would happen to ever want to have a pair of. Or with C# 1.0, I can change everything to be object. So we can change string to object. So let's go into the pair class. Sorry, let's write the test. Let's go do that first. So inside our two doubles here, we're going to go ahead and do a pair. We're going to take a pair of doubles. And we're going to say pair, pair. And we're going to pass in a double. So 140.6 and 70.3. And we'll close that out. And immediately we're going to get a compile error. Got a compile problem. So we need to change the definition of our pair. You can call verify pair while we're there. We're going to have to change the definition of our pair to actually allow us to pass in doubles. So let's go to pair and modify it. And instead of string, let's just do a search and replace, Control H. We're going to go ahead and replace string with object. Now, everything in the system is an object. So everything will cast successfully to object. So now I've just gone ahead and changed it, except there's a problem. You'll notice in my constructor, I ensure, and this is just code that I want to write, I ensure that the pairs get inserted in alphabetical order or in sequential order. So the problem is object doesn't support the method compare to. I have to somehow say, make it compare to. And the way I'm going to do that, I'm going to have to cast it to say, let's go ahead and cast it to an iComparable. By casting it to iComparable, I can still store objects, and now I can go ahead and check and make sure they stay in order. But there's a problem, a subtle problem going on here. What happens if I go collect something that does not support the iComparable interface? I'm going to get a runtime error. And there's no way the compiler can do anything about it. That's where we're at today. Okay, let's go back to our test. There's one other thing that's worth observing about our pair. If we go do a pair dot, let's go up to the previous method and we do a pair dot item 1. You'll notice that when we do pair dot item 1, the only methods available for us are the ones that are in object. Even though I know, I can scan this code, I can see this is a string, the only one that's available for us is the stuff that's inside object. And if I want to actually access this and get the methods that are available to me in string, I have to cast it on the way out. Okay? But there's nothing in here that actually says I have to go ahead and insert a pair. It turns out I could have gone ahead and put a double and a string, and then I could go cast out as a string, and I'm going to get a runtime exception. My goal is to move my errors as close to the code that I'm writing as possible in time. So I really want to get compile errors occurring, not runtime errors. And this is a problem. Right now, the way we've done it, we allow you to collect a pair of everything, anything you like, but I have to go through this cast operation, both inside the constructor and now inside my code when I pull stuff out. There's one other issue that's kind of subtle here. Because I'm using an object, I have this problem that every single time I insert a value type, such as a double, an int, insert a value type into my pair, I'm boxing that value type, which means I'm actually copying the value into the heap. Previously it's on the stack, it's a value type, it's on the stack. But if I cast it to an object, because an object itself is a reference type, I actually copy that data into the heap. And it's a fairly expensive operation if you're going to do it a lot of times. And I have no way around it unless I go ahead and write pair double and just collect doubles, and pair float and just collect floats. So this is the world we're in C# 1.0, and these are the problems with the language. And it was a fairly painful thing for the language team not to add generics. But in C# 2.0, we get generics. Let's see how generics solves these problems. Number one, let's go ahead and change pair. And what we want to do is we want to say, actually, let's do it in the test first. In the pair, what I want to do is I want to say, for this instance of pair, right here, when I'm instantiating the double, with the double, I think, where we're at, the double. When I instantiate it, I want to specify what is the data type you're going to collect. Now, I can't pass it as an argument because it doesn't go inside the parentheses. It's clearly just two items. There's 140.6 and 70.3. I need to pass it as a type argument. So there's some way that I need to go ahead and specify this is the data type that this pair is going to collect. And then when I specify it, it's kind of like I was actually declaring a pair double and a pair float and a pair int and a pair good. I'm doing that, except I'm not actually having to declare it multiple times. I just have one instance of pair, but I'm going to pass in a parameter type that says this is what it is. So let's go and change this. We'll put some angle brackets following the pair, and we're going to go ahead and say, this is a double. If you want to use a pair, you've got to tell me what the data type is you want to collect. And now we're going to go into our pair implementation, and we're going to change the pair implementation to go ahead and accept a parameter, a type argument, to accept a type argument that can identify what are you going to collect in the pair. So here in this type argument, we're going to ahead and type, we're going to change pair, and we're going to say, I allow you, when you instantiate a pair, when you declare a pair, I allow you to specify the type parameter. In fact, you must specify the type parameter. You must specify the type parameter. And if you go back to our test, you see the test is now compiling, at least for the pair case, for the double case. And now we're going to go do a search and replace for pair, and just change that to pair string, and we'll go ahead and replace it so that we now get all of our code compiling when we're back to test running. So the code is back to the compiling. You're going to have to fix that one. However, we haven't improved the code at all because we're still collecting objects. I didn't change pair. I'm still collecting objects. So now if I've passed this parameter in, this type argument into my class, I need some way to use it. So if we go back to pair, we're going to go ahead and do a search and replace. Instead of from string to object, we're going to search and replace object with t. What is t? T is the type parameter that I passed in when I instantiated the type. So now I can do a search and replace with that type. And now basically I'm saying for this instance of t, for this declaration of the variable, it is going to use the type parameter double or the type parameter string. And I've literally changed. Now we go back and look at our problems. Now when I go do a pair.item, you'll notice that I get IntelliSense. And I get IntelliSense for the actual type that I'm using, in this case, which is a string. We've got a 2-upper. Before, that was not available. We had 4 methods. Those are the new 4. But now, because I'm strongly typed, I must be a string, I get to have this effect. First of all, it actually protects me from doing the wrong thing. I can't store an integer with a double anymore. If I do an equals here and go ahead and assign it 15, it's going to say, that don't work. Okay, you can't, because it is strongly typed. It said, you told me this is going to be a string, and I'm going to make sure it is a string. Okay, no more of the any kinds of mistakes that we got before. And lastly, we no longer are boxing because it is actually a double. So because I'm going ahead and providing a double, there's no need for boxing, because actually what happens at compile time, the compiler says, oh, you declared a pair of type double. It will generate the type for you. It will generate you for every single value type. So every single different type of value type will be generated for you. Is that at runtime or compiled? At runtime. Will generate that value for you. And so you have an instance of just that value. By the way, this is different than the way Java does it, but that's just a detail. One more change. I think actually we're good. We're good there. Let me go back to slides quickly. So let's summarize this. First of all, we moved from using object to using a type parameter. And I'm going to make a pretty drastic statement. I believe fairly strongly that certainly with C# 2.0 and C# 3.0, that your coding style will change significantly if you start to use the language to its full fidelity. Specifically, using object within your code should be very, very rare. Very, very rare. If you have the word object in your code and it's not C# 1.0 code, and you have gone ahead and improved it, to be a sort of C# 2.0 style, the word object should be something that sets a flag for you. We call it a code smell. Something's probably wrong, and it should be converted to use a type parameter. I want to be so clear in this. Literally speaking, there is a whole host of collections in system.collections, the namespace system.collections. There's hash tables, right? And there's dictionaries. There's a whole bunch of stuff in the system.collections namespace. Don't use any of them. If Microsoft got to write the framework in C# 2.0 time frame, they would not have created those classes at all. They would not exist. Right? So if you're using things like hash table from those earlier from the system.collections namespace, you should consider rewriting that or changing that to use the actual type, the type that actually matters. Okay, it's a pretty radical statement, but that's one way you can get an idea of your code not meeting the current standards, is to say, hey, am I using types for the system.collections, and it's probably not correct. Okay, so these are pretty radical changes that we're going here. The other thing I would say is you should favor generic collections over arrays. This, again, is a pretty radical statement. You today would probably not, Microsoft would not have declared arrays the way they did if they had generic types in C# 1.0. And if you're using an array specifically, you do need to get a little bit more syntax that I haven't gone through in the 3.0 time frame. But if you're using arrays today, you should replace that or move towards replacing that. You should consider replacing it. I don't want to make a vehement statement here. You should consider replacing that with a list. And that would be better code. It would be more, give you more capabilities if you go ahead and switch that. Okay, so that's a pretty significant change to the language. We got IntelliSense, we reduced the boxing, and we moved compilers into runtime. Collection initializers. This is the other thing you need for arrays to work. Can we just go down to the link statements at the very bottom? 8. You'll notice here I'm declaring a list. We got to switch. Thank you. I knew I had an audience for a reason. You'll notice here I'm declaring a list, and I instantiate the instance, and immediately after I instantiate the instance, I have some curly brackets where I'm explicitly identifying the types that are going to go into this collection, just like I would with an array. And so here, starting with C# 3.0, we can actually do what's called the collection initializer, where we can specify the literal data types that are going to go into this array at compile time, rather than calling list.add, 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 list.add. And this is what enables us to get the full fidelity of replacing arrays with something like list, with generic collections. Okay, we're good. Let's go back up to the top. I want to give one more example of a generic type, and that's the type of nullable. What happens today when you are interfacing with the database and the database has allow nulls on a column? If you've got allow nulls in a column and you've got an entity that stores an integer, there's this impedance mismatch. So you're unable to go ahead and store this data that allows null into my integer. And what I end up having to do is have two properties, right? One that says it has value, another one that says the actual value. And then, I sort of store those for my int. I have to have these two properties every single time because I want to know whether there was data or not data. Well, it turns out in C# 2.0, Microsoft wrote a class called Nullable. Let's go ahead and use that. So we're going to go ahead and type Nullable. And Nullable works only for value types. Since reference types can take null, can store null, we don't need to use null for reference type. We only need for value types. So you can take a nullable and declare an x and say nullable equals null. Nullable equals null. And now that I've done this, I can actually go check, is this value for this integer null or not? I can actually say x dot has value. If it has a value, then I can actually go ahead and say y equals x dot value. Okay? And if it doesn't, then I can go ahead and assign it a default. And then this again, C# 2.0 syntax. I can say, give me the default of the int. And it would automatically go at compile time and say, well, default of int is a 0, so I'm going to go ahead and assign 0. Now, it turns out that this can be done. It is impossible for an int to contain every single option of what nullable int can store because a nullable int can actually contain a null, and you can't assign null to an int. Okay? But I could explicitly cast. So instead of actually doing the x dot value there, up where y equals x dot value, I actually could say y equals int, y equals int and cast it to go into y, as long as I know x does not contain null. And I know that if you go further down a few lines, you can see that I know it doesn't contain null. Okay? So you can explicitly check. And if you know you're not going to contain null, you can just go ahead and do that cast. The other way, if you're casting from y into int, it is implicit. All the possible values that you could have for y will successfully convert into a nullable int, and therefore I can just go ahead and implicitly assign those. So x can be assigned to y without thinking about it. The other thing, you'll notice I'm doing this query where I'm saying if has value, then use the default. I can actually put that in one line. I can replace that with the codeless operator. So there's a new operator introduced in C# 2.0 where I can say y equals question mark, which basically says, if x does not equal null, then just assign it. However, if it does equal null, then use the value to the right of the coalesce operator, and here I'm going to go ahead and say 42, or default of int. Right? So there's a way to automatically say, make the check, verify whether it does or doesn't contain null, and then assign it, rather than writing that big if-else statement that we had earlier. One more thing, there's a shorthand. It turns out that the frequency with which us wanting to do a nullable type occurs so often, we can simply declare that type with a question mark. So I can actually go int dot question mark equals, and I am essentially doing the same thing, the equivalent, the exact, from a post-compile time perspective, it is identical code, it is a nullable int. So an int question mark is the equivalent at the IL level of a nullable int. And now I have a type that can, now I have an integer type, a value type that can store null. Great. And I think that, so that covers, I think I've talked about each of these things. So I did talk about the implicit and explicit cast, right? Casting from a nullable int to an integer is an explicit cast, and casting the other way is not. Okay, we're good. Next, let's go ahead and define pair, but instead of insisting that the pair has to be the same type, let's allow it to be two different types. Maybe like named value pair, for example. So we want to go ahead and declare pair inside our test. We want to say pair, and we want to specify not just one, we want to specify two. Let's go ahead and say name, string, comma, double. Pair equals, and then we want to go ahead and instantiate one of these. Your pair is spelled incorrectly. So now I want to have two type parameters. Okay, two type parameters. I essentially want to support the concept of overloading but it's with, type arguments. I want to override the number of type arguments I can have. I still want to have the data type called pair, but I want to allow me to have multiple types. So the way we're going to do this is we're going to go ahead back into our pair class in the same file. The coding standard is generally in the same file. We're going to cut and paste that code, and we're going to go ahead and allow it two type parameters, T and U. What do you put in? T and V. Right? So now I've got T and V to allow two type parameters coming in, and then I can go ahead and change all the occurrences of T, well not, sorry, the right occurrences of T, whether it's item 2, to be V. And now I can actually store two different data types. Now, essentially, you could use this one as the exact same one as last time. You just pass in two types. So I could do pair back in my test. I can declare pair, string, comma, string, and I have the equivalent of pair of string where it was a single data type. Except because I allow you to not sort them, I don't bother to sort them when I do my second declaration. When I have two type arguments, I decided to do it as a separate class. Okay? You can do inheritance. You can do a whole bunch of refactoring here. I think for simplicity's sake, in this particular case, I would not do that. But you can certainly share code between your classes. So our pair could actually go ahead and use a pair of T could actually go ahead and use the pair of T comma V. But in this case, I think that would, there's too much functionality that's part of the string. And we get strongly typedness here. So here we're going to go do an item dot. If we do an item dot, you'll see that it actually is a string specifically. And here for the int, we actually have the data type of actually int. So it knows what the data type is, and it can start using it. Generic constraints. Let's switch for a second and go do generic constraints. There's still a problem with the code we had when we were working with generics. If you go and look at the pair, we still have this cast. We have a cast to compare, to comparable. And why is this a problem? If we go back to our tests, and we go ahead and pass in person objects. So a pair of person objects, we go ahead and declare that, equals new pair. Just pass in null to make it easy for now. So obviously, you can use a type, right? This is a reference type, so you could actually declare a person. But now if we go ahead and run this code, we're going to get an exception. And the exception is going to tell us, hey, I can't convert this person object to comparable because the person doesn't implement comparable. But it was a runtime error. What I want is a compile time error. And to fix that, I'm going to go into my pair, and I'm going to say, don't allow somebody to use this type with a type argument that does not support iComparable or iComparable of T. So we're going to add what's called a constraint. So following the pair, we're going to go ahead and put a where T for the type parameter, colon, implements iComparable of T. And now when we compile, so a couple things, that's a good point. So we can actually delete our cast here. This is great. We no longer have to cast at all because it knows, because I implement iComparable, then I must have a method of compare to. It's guaranteed to be there by the compiler. And furthermore, when I go back to my test, you'll notice that person is no longer a valid type argument. I have to go ahead and implement iComparable on person, otherwise this won't be allowed. So I'm moving my error from runtime to compile time. You should absolutely take advantage of generics. Make sure you use the most restrictive thing you can in your type arguments to prevent you from getting these runtime errors. Let's go ahead and implement on person. We'll go implement iComparable and get our code back to compiling. So use generic constraints, use them liberally, use in place of explicit cast operations. If you're doing explicit cast operation with inside your generic declaration, you should replace that with a constraint. You should replace it with a constraint. Couple notes. You can have multiple constraints. So you can say you can say that T must implement iComparable, and it must be a struct. It must be a value type, for example, just by following with a comma. Or you could say it must be a reference type by go ahead and type in class. So there's additional constraints. You can have multiple interfaces. I can go and say iComparable of T and iComparable. Right? I can have multiple interfaces on there, classes that just like that. Okay? The thing to note, you got to have class last. The thing to note is that the comma between the constraints is an AND operator. You can't have an OR operator. They must all meet the criteria. they must all, ALL, meet the criteria, not just some of them. So this is an AND operator. Okay? The other thing is you can't go ahead and specify a constraint for operators like equals. So I literally cannot compare two types using the equals operator because there is no interface that says equals. You can't define an interface for operators. Okay, let's go. Keep going. Scroll down. Okay, one more change we want to make. So that pretty much covers generics. Any questions on generics? Anything that came up there? Okay. Let's go ahead and do something that actually came out in C# 2.0, but is fairly rare. For those of you who've ever tried to implement a collection, it takes a lot of work. The ability for you to have a collection and do a for each loop over something, over an object, requires not only implementing IEnumerable, but also requires you creating a new type that implements IEnumerator. And there's a fairly complex pattern. You have to worry about multiple threads and a whole bunch of stuff and how many times it's going to be called and what if you nest your for each loops. It's fairly difficult to do, except in C# 2.0. It gets a lot easier. So let's imagine we have a pair and we want to do a for each loop over our pair. Right now there's no functionality. There's only a dot item 1 and a dot item 2. That's all you can do. And you notice we're getting a compile error. It's telling, hey, I can't iterate. I can't go do move next on this loop. But I want to go ahead and implement this functionality, and it's really easy. It turns out, if I go into my implementation of pair, I can literally go ahead and say that it implements IEnumerable of T. Okay, before we go on, first of all, note that we have generics in interfaces as well. And you can pass the type argument that comes in for the pair and use that type argument again in my interface declaration where it also takes a T. So interfaces have type arguments too, and they're really useful and really important. So here we're going to go ahead and implement it. Let's generate that implementation, control period enter. And we're going to go scroll down, and it's gone ahead, and IEnumerable derives from IEnumerable of T, the generic version, derives from IEnumerable, the 1.0 version. And so to implement this, we're just going to go ahead and have the 1.0 version call the 2.0 version. So we're going to have the 1.0 version call the IEnumerable of T. So we just call from one to the other. And now we're going to go ahead and implement this getEnumerator. And it turns out it's only six words. We're going to type yield return item 1 and yield return item 2, and that's it. Semicolons. What language are we in? Yeah, semicolons after that. What's going on? Let's put a breakpoint on our yield. Let's go back to our for each loop. And let's go ahead and put a breakpoint in the for each. And let's step through this. Control R, T. Control R, Control T. Step through our test. So what it's going to do is it's going to go to the for each loop. At compile time, the types that implement IEnumerable were generated for us, and the type that implements implements enumerator of T was generated for us. So now when we do an F11, we're going to go to the names. It's going to say, go ahead and give me the next. It does a move next, which means move to the next item inside your iterator. We go ahead and put an F11. Now we're inside the getEnumerator implementation. This is what IEnumerable did. And we do a yield return 1. Now note, this is very important. Logically, what happens in the code was when it hits a yield return item 1, it literally jumps from here back to our for each loop. And we now have item set to be item 1 from our collection. It goes ahead and does an assert, and the code essentially back in our yield has essentially stopped. Logically, it stopped executing right there and said, go ahead and finish your execution, and then when you want another one, then call me and I'll continue to execute. So it jumped out of that one location. Now it's saying, give me the next value. It's jumped back to the next line and saying, okay, give me the next one. And then it goes in and stops, jumps back out again. It's going, here it is. And it jumps back out of that method. We're just doing F11. We're just stepping through the code. Now we're back and we're iterating through the next item in the pair. We step over that. We now go back and we're going to go do one more time. And now we're at the end of the method. There are no more yield statements. So we're done and we're going to drop out of the for each loop. And we're done executing. Okay? This is extremely powerful. If you have to write collections, you will almost always do it using a yield. In fact, there are no examples that I know of where you would not use yield if you were implementing a collection. And there's no examples because the compiler does it for you. right, in a thread-safe way, and it obeys all the rules and obeys all the patterns. It's great. Okay, that's great. One other thing to note about this is that it does it not only for when you have a method that returns an enumerator, because the getEnumerator returns an enumerator. You can also do it for methods that return an IEnumerable. So if you wanted to say return reverse, where you want to return the paired in reverse, you could go and return an IEnumerable, and you could also use yield in that case. So the rules for using the yield statement, the yield return statement, is that you must return from your method either an enumerator or an IEnumerable, an enumerator of t or an IEnumerable of t. I think that's it. We're good. Next, we're going to move into C# 3.0, and we're going to talk about extension methods. Let's imagine that we want to go ahead and write an implementation of pair. We want to go ahead and allow you to return the pair of items in random order. We want to return the pair of items in random order. We're not going to return a pair specifically. We're going to return an IEnumerable, which means we're going to return a collection. So we're going to take, given a pair, we want to do a dot randomize and get returned back an IEnumerable, a collection of items that are in random order. And we're going to do that for a pair. But we're not going to just do it for a pair. It seems like this would be a fairly useful thing, especially in testing. This would be fairly useful for all types of collections. All collections. By definition, a type is a collection if it implements IEnumerable. And we're saying, I want to go ahead and have all collections have a randomized function. Randomized function on them. Okay? So we're going to go ahead and write that function. And we're going to put it in a class called collections, which I've already started to create. We're going to jump into collection. And inside here, we've got a static collection with a static class that takes the enumerable, takes a collection. Remember, our pair implements IEnumerable of t now, so it can go ahead and receive that pair. And it returns an IEnumerable, but it's going to return them in random order. You can show them the code, but this code is, I haven't explained all this code yet, so I've hidden it right there. But that's what the code does. It just returns the items in random order. And now if we go back to our test, we can go ahead and execute that. And it's fairly painful to actually go verify that they were returned in random order. So you can ignore the complexity here. Just pretend that this is really trivial to go ahead and verify. And you'll see that our test is passing and they are returning random item. The first for loop was just because random of a pair is fairly frequent, the same thing as it was. We executed enough times to make sure that they are indeed random, or that at least it changes. Okay, let's go ahead and do the same thing on something that's not a pair. Let's go ahead and do this on our list, or IEnumerable. So here we go ahead and we instantiate a list like we would do an array. We assign it to a variable called before of type IEnumerable because it's a collection. And then we're going to go ahead and call collection.randomize. Okay? We're going to go and call collection.randomize. And you'll notice in this case, we're just checking that it's not equal. We're hoping that there's enough items here that usually it won't be. This test is not a good test. We should have it iterate many times, but for simplicity's sake, we're being lax here. So we go ahead and call randomize, and we're going to make sure that these things are not equal. Notice, in this case, we're calling collection.randomize. What I really want to do is I want to have this method called randomize actually on the collection. I want to have all collections have this method called randomize, and I want to have it be discoverable. I want to do before.randomize exactly like that with IntelliSense, so that I know whenever I've got a collection, I call a .randomize method. What I'm essentially doing is say, I think there's a method that Microsoft forgot to write, an IEnumerable. And it's really useful to me, and I would like for all of their types that implement IEnumerable to have this method. Okay? I want to extend it. I want to add additional methods to a type I don't control. I do not control the IEnumerable interface, right? That's in Microsoft's code. And I'm pretty sure if I asked them to add my method, they wouldn't think it's such a great idea. Would you consider it? No, he wouldn't consider it. Okay. So I want this ability, and and actually Microsoft wants this ability too. In the C# 3.0 world, this is literally what happened. Many, many times people said, I want to work with a collection, and I have to filter the collection. I want to do a where clause on my collection. I have to project out of the collection. I want to just get parts of the collection. I want to change the data type. okay? Or when I group items in the collection. And so Microsoft themselves wanted to extend this interface and add additional functionality, okay? But to do that, they would have to change IEnumerable so that it had the additional things, which means if you implemented a collection, your collection would no longer compile. Or they had to force all collections to magically have an additional interface, which they couldn't because there were already collections implemented and nobody wrote the code for the additional interface. So Microsoft had the same problem that I do. They wanted to add methods to all collections and do it in a way that would not break existing code. And so what they did is allowed you to define an extension method. Let's go back into our randomized implementation. You'll notice my collection is static, requirement number 1. My method is static, obviously, since the class, my class is static, and obviously the method inside there is static as well. And then I'm going to add a modifier right before the first parameter, and the modifier is going to be this, the keyword this. And now if I go back to my code, I magically have a randomized method on my collection. Be very clear about this. You could add a method to a string, one that Microsoft hadn't thought. What about an encrypt method? I would love to have a string. I'd like to have an encrypt method. You could write an extension method inside a static class, static method, prefix the data type that you want to extend with this, and you're done. Okay? And you can literally extend any type like that. And that's exactly what Microsoft did for IEnumerable. And this is what gives us the power of LINQ. And it is very powerful. Couple things to note. Generally, when developers first encounter the extension methods, they are very excited. They have always thought about things they want to extend and put methods on where places that Microsoft didn't put them. And they're like, great, this is a fantastic opportunity for me to go ahead and put methods on that Microsoft was too, fill in your blank, to think of themselves. Okay? Don't. I strongly caution you against using extension methods unless you're absolutely sure it is a valid scenario. These are some tips about valid scenarios. Number 1, it is extremely rare. I don't know of any cases that Microsoft did this in the entire framework where they extended a type that was not an interface. Okay? They extended a type that was not an interface. It is extremely rare for you to put an extension method for something that you control and can change. Classes you control, you can change them. Don't bother to make an extension method, control it and just put the actual method in. Okay? Microsoft couldn't change IEnumerable. Even though they controlled the code, they couldn't change it because other people have implemented it, they would have broken. Okay? So even though it seems an awesome opportunity for us to create the blah method that we've always wanted to have, don't do it. Use extension methods gingerly. Okay? Be very cautious. And the general guidelines are use them on interfaces and use them on types that you can't control and you really need. Now, that's the guideline. If you have an explicit reason to change it, identify what the explicit reason is, document why you're going to do it, then by all means do it. But don't overuse extension methods. One of the hardest things, I have this occurring, there's some WCF code right now coming out of the Web API kit, extension kit. And literally, there's extension methods. You can see the sample code online. I see, oh, this is great. There's the extension. And I type, and there's no IntelliSense. It's not appearing. What is going on? Why can I not use this type? The first rule is I have to actually import that namespace and with a using statement at the top of my code. That would allow me to use the type. Collections has to be part of my namespace. Rule number 1. Rule number 2. That's one rule. The next mistake is don't ever go put your extension methods in a different library than the ones that you've already working with. So here in the case that I'm talking about with the Web Extension API, they defined extension methods that and I didn't know they're extension methods because I just looked at the code. I just looked, I was a member of the type, right? But not only did I have to import the right namespace, I actually had to go reference another entirely different library and then import the namespace in order for me to have access to this type. And by the way, you can't use the refactoring tools from Microsoft to go suddenly get this library imported so you can start working with the method. So you end up searching the internet for where the heck is this extension method? How are they doing this? Where does it belong? Where does it own? And it becomes a problem. So be cautious about using extension methods. Question. Loudly. Loudly. So the question was, in ASP.NET, I extended the response header, is that what we said? The response redirect to add an additional method to open another window. So my caution to you is, first of all, does it meet the criteria? Is it an NFS that you were implementing? No. Okay. Is it a type that you control? No, it's not. So you got one of the two. I would be suspicious, right? I can't talk out of context of the code, but it's something that would say, go back to rule number 1, don't do it. And then if you can justify it, it's okay, but use these gingerly. I'm not trying to make a blanket rule, never write extension methods. That's not what I'm saying. I'm saying be very cautious. They're fairly rare, fairly unusual. If you can call them just as a regular static method. Is it justified, and is there a need for discoverability here that's important enough to warrant creating an extension method? So I'm not saying no, I'm not saying it's wrong, but be careful, right? That's what I'm saying. Okay, let's go on. We're going to spend some time in LINQ. I talked about C# 2.0 and how that radically transforms your code. Basically, you start never using an object or working with an object. And that was a significant change to the language. How many of you work with collections? Collections, dictionaries, hash tables, that kind of stuff. If you work with a collection, this should significantly change your programming style. Okay? The way you code will significantly change because of LINQ if you work with collections. I did a talk a couple of years at TechEd, maybe the person's here, I'm not sure, and they came up to me, they said, Mark, I just don't see where I'm going to use LINQ. And I said, don't you have collections? He said, no. I said, you're right. If you don't have collections, you're never going to use LINQ. Okay? But if you have collections, arrays, lists, dictionaries, you're going to use this, and it should radically transform the way you program. Let's talk about what's going on. There's a class called IEnumerable. There's a class called enumerable. Can you type enumerable and just browse into it? And in the enumerable class, Microsoft has gone ahead and written a whole bunch of extension methods. Here there are. There's something like 68 of them or something like that. Lots of overloading. And you notice they're all extension methods because the very first parameter is an IEnumerable. They're extensions of IEnumerable. The very first parameter is prefixed with a modifier of this. It's in a static class. Enumerable is a static class. And the methods are all static. So literally, Microsoft has said there are many, many, many extension methods that should be available to you if you're working with collections. And they're all defined inside this class enumerable, which is inside the system.link namespace. If you want to be doing LINQ, you need to go ahead and add a using statement to the top of your file. The Visual Studio does this for you automatically, of system.link. And that allows you, when you're working with collections, to get access to any of those extension methods every single time you do a dot. So here, if we go back to our class, back to our test, and we want to work with our list of items, we can go on those items, we can literally go ahead and do a dot, and we'll see a whole bunch of extension methods come up. You're good, you're good. So here, let's do a before dot, and you'll see we don't just have the methods that are available in IEnumerator, which is one method. Like, so to be very clear, IEnumerable only has one method. The method is getEnumerator. Of course, it has stuff in the base class, object. It has stuff for object like getType. But on IEnumerable, there's only one method. Except you'll see there's a whole host of methods here. And these are all the extension methods that were given to us inside the enumerable class. So now, very common operation. Let's think about the code you would have to write. If you want to take my collection there of all the dwarfs and say, go ahead and select all the dwarfs whose names begin with a capital D. What would we do? We would have to go and declare a variable of type called after that is of list. We would declare the list, and then we'd write a for each loop over all the original items, and we'd go and call after.add, and we'd iterate through literally adding each of the items to the collection. That's the code you write today in your for each loop. Okay? And this is a very common operation. It's a very common operation. Instead, what we're going to do is we're going to move that to one line, and we're going to say new items equals items dot, and we're going to go ahead and call where, just like you would in SQL. We're going to go ahead and say where. This is an extension method. Did we miss out on, we haven't done lambda expressions yet. Lambda expressions, we should cover lambda expressions first. Okay, we're going to take a break. Can you guys pop the stack? Can you handle that for a second? Okay, we're going to pop the stack quickly. We're going to switch and quickly do lambda expressions, because I think we'll go here and we'll end up in a little bit of trouble. So Lambda expressions. I have a type, this type called person. And what I want to do is I want to monitor the property first name. So every single time first name is modified, I get an event notification saying first name changed. The pattern here is the onChanged property, the onProperty changed. There's an interface for it. We're not going to use the interface for some detailed reasons, but we're going to go ahead and allow us to monitor any changes to this, this property. So to do that, let's go ahead. We need to have a delegate defined. We need to have an event defined on our person object. Okay, so we want to go ahead and type person.onPropertyChanged for the event that we're going to have, but there is no onPropertyChanged event. So let's first go and define that onside person. So we drill into person. Now this is standard 1.0 stuff. In 1.0, in order for you to go ahead and declare an event, you must have a delegate. Okay, so we must declare a delegate. So outside the class, we're going to write a delegate called onPropertyChangeEventHandler. Okay, onPropertyChangeEventHandler. Now, I want to be careful. There is such a type defined in the framework inside the component model, but I need to do some modifications here, so I'm doing it just to be explicit on what's going on. So we're going to go ahead and define onPropertyChangeEventHandler, and by convention, it has to take an object of type sender, and then something that derives from PropertyChangeEventArgs, and we're going to use the PropertyChangeEventArgs that Microsoft provides for us. Okay, so we've declared our delegate. Now we can go declare our event. So we're going to go up into the class, and we're going to say public event of type PropertyChangeEventHandler, and then we're going to set it, then we're going to give a variable name, so we say onPropertyChange, and then we're going to set it equal to delegate, curly bracket, curly bracket. Anyone know why we assign it to delegate, curly bracket, curly bracket? At the back, we got one person. So if you're actually working with events, one of the things you always have to do, one of the first rules you have to do when you're working with events is you have to check whether the delegate is null or not before you go ahead and fire the event. Right? You have to first check whether it's null or not before you fire the event. And it's a pain in the patootie. Right? Instead of doing that, one shortcut is to initialize your event every single time you declare it with a delegate curly bracket, which basically says set it to a collection of delegates where the collection is of zero, a collection of 0 delegates. Now we don't have to check for null because there is actually an instance of the collection of delegates. There's nothing in that collection. It's an empty collection. Okay? Now, you could delete this assignment. If you go ahead and redo an equal sign here and remove it and set it to null, then you're going to have to be checking for null again. So generally, don't ever assign null to your event. But if you do this, it saves you from cluttering your code everywhere with are you set to equals, are you set to equals, are you set to equals. This, by the way, is called an anonymous method, and it became available in C# 2.0. Okay. Now that we've done that, let's go to our test, and we can finish our declaration. We're going to say property onChanged events plus equals, and we're going to go ahead and call the person property changed method. Standard 1.0 stuff. So now what we're going to have happen is when first name changes, it's going to go ahead and call us back. The class is going to call us back, and it's going to call the property changed event. And we're going to go ahead and set the person property change confirmed to be true so that we can then test that indeed we are getting a callback. One more thing we need to do, we need to actually go implement it. So let's go and go into first name and go ahead and fire the onProperty changed event. So in the set method, following the assignment, we're going to go ahead and call onProperty changed event, and we're going to go ahead and pass it a new, this for the sender, that's us, and a new property changed event args, and we're going to specify the name, which in this case is first name. And let's run our test and verify that's working. Sweet. Okay, so that's standard 1.0 stuff, but it's worthwhile showing all the details that have to go in events. Okay, next. I'm going to take that entire method. Oh, first of all, in C# 2.0, you could actually delete the new. You didn't have to do this anymore because it can be applied. The compiler knows the data type must be a property changed event handler because it knows what the data type of onProperty changed is. So the compiler can imply which, you don't have to do the new statement, it's just implied for you. Next, we can actually take the declaration of a person property changed method and we can paste it over where we had property change and we can delete void. Okay? Now, we've literally taken the method and moved it up as though it's inline. We're declaring a method inline. But we don't need to have a name for it because it doesn't need a name. We're right there. We're right where the call is. So we can just delete the name and we can replace it with the keyword delegate. And now we have literally gone ahead and moved the code. We can run the test. We've literally gone and moved the code from a method outside to a method that's declared inline, and this is known as an anonymous method. Okay, an anonymous method. And so I can literally change. This time I can subscribe to this event. Next time I can subscribe to a different event, right in line with my method. I'm basically writing new methods. At compile time, the compiler is generating that method that I previously declared for myself and giving it some unknown name that you can't access. Okay, that's what the compiler is doing at compile time. Next, before I had to go and do property change confirmed, I had to declare that at the class level as a field. But now I'm not accessing it at the field level. I might as well just move it into my method. So now I can have a local variable, declared person property change confirmed, and I can rename that. It's just lowercase p. And now that method doesn't even exist. Nothing exists regarding the subscription outside of the actual method. I'm doing everything in line. Okay? And that gives us anonymous methods, and it does exactly all the stuff that we were doing before. Okay. Next. It turns out I want to do one more show of generics. There's something else about generics that we need to show you. We should do that now? Okay. We're going to do lambda syntax. Let me first do this. We're going to go ahead and let's transform this anonymous method to a lambda expression. A lambda expression. This is C# 3.0. I show this in my slide later on. One thing I can tell you about this. Become very comfortable with lambda expressions. Delegate syntax like this is only used in the one case I showed you where I initialize my method. You should become very comfortable with lambda syntax. Okay? Let's go ahead and do it. Let's go ahead and delete the keyword delegate and replace it on the other side of the variable declaration with a fat arrow operator equals greater than. And we're done. Can you put that on the same line? So let's move object, the beginning of the expression, to a new line. I now have a lambda expression. In this case, it's called a lambda statement, actually, because I've got curly brackets, so it's a statement. The exact same code. I haven't changed anything. I've just moved from a method, standard method, moved it into a delegate, anonymous method, and now I've moved it to become a lambda statement. That's it. Okay? There's a couple of optional things here. The compiler knows that onProperty changed is a property changed event handler, so it knows that the data type of the first parameter is object, and it knows the data type of the second parameter is property changed event args. So I can just remove those from my declaration. We'll just go ahead and delete those. So now my statements can become more concise. And secondly, it turns out that assigning a variable is actually an expression, so I don't need to have curly brackets here. I can just literally go ahead and delete the curly brackets, and now I've got it back to an expression. Okay? There's nothing significantly different between a lambda statement and a lambda expression. It's just whether it's got the curly brackets or not. Okay? But I have the exact same code I had before with a method declared outside. I've just moved it all in line. This is very, very powerful. Okay? Become very comfortable. The first time I talk to people and I show them the syntax, they're like, equals what? You know, equals greater than a fat arrow? What are you talking about, right? So the way you say this is you say, the onProperty changed event is subscribing to sender, comma, center goes to property change confirmed equals true. Okay, that's what we're actually executing. That's how we sort of say it, or subscribes to. Okay, we're testing. The test is passing. We're good? Okay, one more change I want to make back in the person class. We declared a delegate of type property changed event handler. It turns out that Microsoft provided for us a generic handler. What we want to do is, instead of going ahead and declaring a different handler every single time that we're working, a different event handler, we just want to change one thing, a type parameter. We just want to change the event args type. Sometimes it's a property changed event arg, sometimes it's an exception event args. We just want to change that one type. If you just want to change the one type, it's just a generic. So Microsoft went and defined for us an event handler that takes a single type argument, and we can actually go ahead and change our subscription to use that. We can actually change our event to now use the event handler. So you don't ever need to declare your event, you don't ever need to declare your delegates explicitly yourself. There are a few rare cases where you will, is because the type parameters are unclear. Remember when we had, if you have 10 type parameters, it's not really clear what each type parameter is for, you could go ahead and explicitly define your own event handler, because T is not very different from, T1 is not very different from T2, different from T3. So you may want to declare your own delegate. It's a fairly rare thing to do. Fairly rare that you go ahead and do that. Okay, so so the important thing to note is we're using generics over again. We're taking that same knowledge we learned from C# 2.0 and we're reusing it here as a generic. There's two other generics delegates that I'd like to introduce you to. One is a func. Okay, a func. A func is a delegate for any function that returns a parameter. Any function that returns a parameter, you can go and declare a delegate of type func. And it takes up to like 16 different type parameters. I mean, this is like mega extreme. Do not write code that takes 16 different type parameters. But Microsoft is special. You know, we got to give them credit. So it takes literally 16 different type parameters. And the point is, you can declare a delegate that returns a type of your choosing, and then you can pass n number of parameters into that type. Become very comfortable with func. It is just a delegate. It just happens to be generic. So take your knowledge from 2.0, apply it in the 3.0 world, and you've got the same functionality. Okay? The other one is action. Action is a data type. It is a delegate that only returns void. So an action returns void. So those are the two types you need to know. Action and func. And they're used all over the place. There's one other predicate, but you don't need to know about it explicitly because a func handles the same thing the predicate handles. Okay, let me go back to slides quickly. Talked about extension methods, generic delegates. So I've talked about this. Specifically, you should favor using event handler, action, and func. And yes, you've got an explicit reason not to. So rather than declaring your own delegates, go ahead and use these ones. We talked about lambda expressions. These replace explicit method declaration. That's a big deal. That doesn't mean you always should use it, but you should definitely, if it's not going to be called from multiple places outside of your class, use an expression. Use a lambda rather than going ahead and using a explicit method. It enables passing local variables. Remember, I moved the confirmed property change event confirmed. I just moved that into be a local variable. I didn't have to go declare it outside of the method because I wasn't passing data in the same way. The compiler is doing that all for me. Reality is the generated code will look exactly like mine. Names are different, but it looks exactly like mine internally. But for all practical purposes, I don't need to know about that detail. You can get lambda expressions both in statement form and in expression form. And you should embrace these. So if you've been kind of reluctant, I don't like the syntax, I would prefer the way the VB does it, whatever you want to say, just embrace these. Take the time, take the hour, 2 hours, I think that chapter is actually available, that chapter from my book is available for free. You can just download it. Take the time to do it. Learn and become comfortable with lambda expressions because they are used all over the place when you start programming with collections and using LINQ. Okay? Questions? Okay. Oh, one here. That's a great question. The question was, when you go ahead and declare a nullable type, what is the default value? The default value for a nullable type is null. It's a great question. Default value for a nullable type is null. Lucien's going to prove it for you. You shouldn't do this. We didn't practice this. You're not supposed to do things you never tried beforehand.
Hey, I'm not going to run it.
Oh, okay. That's okay then. Just kidding. I don't know if you guys know, but there's this rule for lawyers. Lawyers should never ask questions that they don't know the answer to. Right? You should never ask a question of a witness that you don't know the answer to. Trainers have the same deal, right? You should never do a demo you haven't done before, right? I break that rule all the time. Okay. So now we're going to go ahead and use those lambda expressions. We're going to start using them all over the place. I talked before about using the for each loop to go ahead and filter out and just get the items that begin with capital D. Let's go ahead and do that now with a lambda expression. We're going to go ahead and say items equals items dot where. And you'll notice the data type here is a func. Okay, the data type is a func. I just introduced the func a little bit earlier. A func returns a bool and takes a string as a parameter. How did it know that it was a string? It knows that it's a string because items collects strings. It knows that because it's enumerable of type string. So we're taking all the stuff we've learned so far and we're reusing it here inside our lambda expression when we start using LINQ. Okay, items dot where. We've got to write an expression, a lambda expression here, a method if you like. We're going to write a method that takes a string and returns a Boolean. Okay, let's go ahead and do that. We're going to say item goes to, okay, there's the string, the item is a string, that's the item that collect iterating over, where the first character equals D. Okay, first character equals D. It turns out there's an abbreviation or there's a shortening here. We don't need to have parentheses when there's only one argument, so we can go ahead and remove those, and now we've got a sort of a very short lambda expression here, where item goes to items, item returns, in this case, a bool where the item is equal to D. The first letter is equal to D. Okay? And I'm literally selecting out of my collection all of the strings that begin with a capital D. Think about your database query. It's exactly like a database query. I'm saying select from this table, my table is called items, select from items where the first letter begins with D. I'm doing the same thing. And literally, we're not going to cover it here, but there's other sessions on the Entity Framework. Literally, that's exactly what the Entity Framework enables you to do, is to write syntax in C# that pulls data out of the database. And it's all based on understanding LINQ, in this case, LINQ to objects. We have now gone ahead and filtered this collection so that horizontally we're saying it's not this many items, it's only this many items. If we filtered our database, we pulled data out of the table, and we're saying it's not all the records, we just want this selection of records, and we've identified the criteria using a predicate. We've identified the criteria of what we want to select. Sometimes, however, we work with tables that are really large. You know, hypothetically speaking, you might have an Oracle table that has like 400 columns in it, right? I'm sure none of you guys do, but maybe somebody sitting next to you, something like that, right? So you've got these tables that are just ginormous, and you can't go ahead and declare a type with every single column in it in C#. Because if you declared that type, every single time you queried and pulled the data back, you'd be getting all that data, and really you only need 5 columns or 3 columns, okay? So we want to project, we want to take that original piece of data and we want to project it into a smaller set or a different set of data. In our case, the first time, we want to project and we say, take that original collection, let's go ahead and transform the strings into integers where the integer is the length of each string. So we're projecting what was originally here as a string, like projecting that out and saying, just give me the length as a totally different type. And the way we do that is using select. So you'll notice on items, we now have a select method. The select method takes a string as the item, and it returns anything you like. Okay? But we've explicitly said we're going to return an int because the resulting collection is a collection of integers. So we're going to return an int, and here we're going to go ahead and say select out the item where the select out the item length, and we can go and actually iterate over that to go see the values. Notice length dot. If I do length dot, each one of the items in here actually that won't work, but length dot. Each one of the items in here is actually an integer, right? Because I transformed what I originally had to be this. Okay. Something important to understand about this. These LINQ extension methods are so powerful that you can start doing queries using multiple threads. There are extension methods that you can literally go, well, here I've done a query. I said, okay, let's do a select. And I passed some algorithm. In this case, it's very simple. But let's imagine I've got a huge collection and I'm doing something complex. I'm doing some kind of complex projection, or I'm filtering, and there's a complex algorithm to figure out what it is. And I wanted to run those things in parallel. Okay, I want to run that in parallel. Now, you can go, there's lots of talks in parallel. No, not anymore. I think they're all finished. But there were lots of talks. You could go get them. You can go learn all about parallel and all the complexity that's involved in there, and it takes a lot of time. Or you can literally do a dot operation, and you can do dot as parallel. And now I've just converted my select statement to execute in parallel. And you can do this for all your queries. That doesn't mean they'll all be faster. When you start to do operations in parallel, you need to think about it, and you still need to worry about synchronization, but you don't have to worry about how many threads have been instantiated. And so if you've got expensive operations, and you understand how to lock stuff correctly and appropriately and worry about synchronization, you can literally start transforming your queries to be running in parallel instead of on a single thread, simply by doing a dot as parallel in the method. Okay? Very powerful, very simple to get there. Questions about this? Would this fail the test case? So the statement here was that would fail the test case, and he's absolutely right. The test will fail because the items could be returned in different order. It just depends on how many times I run it. I'm sure if I ran it enough times, I could get one case where it would pass. Yes, I totally agree. He's absolutely correct. If I ran this test, it would fail most of the time. Okay, so LINQ should transform the way you work with collections. It enables us to do object relational mapping, to go ahead and retrieve data from my database and interact with that data using C# code rather than using SQL code. We don't no longer have to worry about where do I store my SQL string, because the SQL string is actually stored in your C# code and generated on the fly for you. You don't have to worry about that. It's fully strongly typed. So you'll notice when we did item goes to item dot, we did an item square operator, it knows exactly that this is a string, this is what you're working with, and so I get full compile time validation over these strongly typed instances of data. Okay? Embrace LINQ, use it often. Okay, let's go back. There's one other thing I want to show you here that's related to LINQ. Remember I talked about this huge table with all this data, and then I went ahead and did a projection. In this case, I transformed a string to be an int. Let's imagine that the data type, I've decided for this, in this method, I want to go ahead and get out just 5 columns, and I want to randomly choose which 5 they are. To do that, I would have to go declare a new type, with specifically those columns in it, and then I want to go ahead and do a dot select statement to transform, to pull out just that type of data from my table. However, this is frequent where the data that you want to pull out changes. In one case, it may be these 5 columns. The next case, it may be those 5 columns. Sometimes you want to transform it completely radically and create a new type that didn't exist before. It turns out that we can, on the fly, declare new types without using class and putting them in their own file. We can create what's called an anonymous type. The first thing that we needed to do in order to support this functionality was we needed to be able to name that type without, giving it its own independent name. So there's a new variable type, new type parameter or data type called var. I can go ahead and say var dwarf entity equals new curly bracket. Just like I would declare a class, say new curly bracket, and then I can go ahead and say name equals da, comma, ID equals GUID dot new GUID, comma, height equals 6.5. That would be kind of tall. Maybe we should go with 3.5. What is the data type of dwarf entity? I have no stinking clue, right? And it doesn't matter because I can't reference it. I can't use it as a parameter, or I can't write that name anyway. It can't be used inside a method signature. Okay, I don't know what the data type is. On the fly, at compile time, the compiler will generate a type for me. And it's strongly typed. If I go to dwarf entity dot, you'll notice that it actually has a name property on it. And it is a string, right? A name property, and it's actually a string. It actually has an ID property, and the ID property is actually a GUID, right? On the fly, I've generated a type. And this allows me to, within a method, go ahead and create new types of objects and start interacting with those. In addition, I can go and type var space text equals Inigo Montoya. This is identical, post-compile time, this is identical to writing string text equals. Okay, those two things are the same thing. You can't tell an eye level that there's any difference. Okay? This means, and you'll see this, I'm sure you saw this this week, people will start to use var everywhere rather than going ahead and typing out the type. This is my guideline. You should obviously use var when you have to. The case above, dwarfs entity, I have to use var because I have no name for this data type. I don't have any choice. So if you've got an anonymous type, you must use var. The second time is okay to use var is if the data type is obvious. Okay? Here, the data type of text is obvious. It's a string. I can just glance at the code and go, it's a string. It's no big deal. If to the right of that I had a new text builder, right? So I had var text equals new text builder. The data type is obvious because I've got, on the right of the equal statement, I've got a new text builder. I know what it is. Okay? However, if I had a method, it's not in your namespace, it's okay. If I had a method and I went ahead and said text equals get ID, what is the data type being returned by ID? Whatever you tell me, I'm going to come up with a different one, right? It's not obvious. So if it's not obvious to see what the data type is and you don't have to use var, my guideline is don't use var. Okay? Now, I know there are people in this room, they're walking out because I just said this. No, I'm just kidding. I know there are people that don't hold this as strongly as I do, and you're welcome to that and welcome to code differently. But my coding standard, my guideline is that you only use var when it is explicitly obvious, when it's explicitly obvious what the data type is. And this is especially important when you start to interact with LINQ and you get complex data types back. You get an IEnumerable of T that's IEnumerable because you used a group by or something like that. Those are the cases where you want to be most lazy, but the consequences are most drastic because you don't actually know what the data type is that you're being returned. So when I do LINQ statements, if I can, I always explicitly say this is the data type and I don't use var. So that's the general guideline. Let's go ahead and do this query. So in this case, what I want to do is I want to go ahead and take my dwarfs, and I want to go ahead and select out of my original collection. I want to go ahead and select the ID, which I'm generating on the fly. I want to take the name, which is actually the item. In this case, I want to take the length, which is the length of the text. Okay? I'm generating a type on the fly, and I'm using the exact same syntax that I did above for the dwarf entity. I'm just using new with curly brackets, just like you declare a class, except I took out the word class, and I took out the name, because I can't name this type. And now my test is not quite going to pass. We're going to have to make a change here. So let's do a select statement on my test. We want to go ahead and do name. Let's do a select. We're going to pull out just the length. Dwarfs dot select dwarf dot length dot toList. And we're passing. So I took my original result, and now I'm doing another select statement out of my anonymous type and starting to interact with it. Notice if you do a dot operator on the dwarf here, it is strongly typed. Can you do that for me? It is strongly typed to the data that's in my anonymous method. Okay, it's the data that's in my anonymous method. Okay. Implicitly typed global rails. I've given these guidelines. I'm not going to go over them again. And we got one more thing to show you. Okay, there's one gotcha. Literally, I remember in C# 1.0, the C# design team had a design principle. Do not do expensive operations implicitly. That was the rule. Do not do expensive operations implicitly. You should be very explicit about going ahead and retrieving tons of data from your database and bringing them all back. It was an important guideline. In C# 3.0, they broke that guideline. And I remember sitting down with the powers that be, Anders and Mads, and we go, how can you guys do this? This principle was so important. What's going on? Let me show you what's happening. Let's go ahead and look at the next method. Here we go ahead and do a where, and in the where statement, in the lambda statement here, I'm incrementing execution count. Okay, I increment execution count. Following this line of code here, where the cursor is, what is the value of execution count? Who says it's 7? The value of execution count, who says it's 7? Who says it's 9? Who says it's 0? Right? Some people say it's 0. And who abstains? Right? So if you look at this code, it seems fairly clear to me that my execution count should be 7. There's 7 items. I've gone ahead and assigned from one collection to the other collection, and my count should be 7. However, if you do an assert statement here, it is not. Okay? I go ahead and do assert the execution count. It's actually only 0. The reason is this statement hasn't actually executed. What that first statement that begins with D is, it says the query for the items is going to be to return only the items that begin with D. It does not execute the query, it just declares a query. The query doesn't actually execute until you actually pull the data out of your begins with result. So here when I do an item.itemcounts.count, in order for me to count the items in IEnumerable, I actually have to iterate over the entire collection. So now, after I've executed count, my execution count is now 7. Keep going down. Next, if you iterate over all the items, each time you do that, you're going to do a for each loop. You've taken all the items, you've pulled them back from your database, and you're going to start iterating over them. This, again, is going to increment the execution count every time for begins with, because I'm going to take the query, I'm going to execute the query. So that, again, is going to change my execution count to be 14. Okay? Now, surely, if I've already queried all the data back and I've done it once, why am I doing it again? If I do another for each loop, like I do 2 of these right after each other, surely that's not going to re-execute the query over the distributed wire back to the database, running in that place that I can't say, but it's out there in this, nice white fluffy place, right? When it goes and executes, and surely it's not going to do it again because I'm iterating the second time, right, in the for each loop, but it does. My for each loop is going to now execute that same statement and pull all that data back again. And my execution count is again incrementing to 21. Okay? Be very aware that this is going on. Be very aware that this is going on. If you need to prevent it, you simply cache the items. Okay? And to cache the items, I'm now going to say begins with D dot to list. I'm saying go ahead and take what you originally had, cast it to a list, and reassign it back to the original value. And now I've got the items. I actually executed the query and placed all the items into a list. Okay? So now when I iterate again, 28, the next time I do it, my execution count is not going to change. Sorry, let me rephrase. In order for me to put it into the list, there the execution count incremented. So now it's in the cache, but I had to increment 28. But if I now do the for each loop over it, they won't do it again. It won't increment again. Okay? So be aware. This is the right thing. It was the right design decision for Microsoft. Deferred execution gives us the full capabilities that Lync has. Okay? But there is this subtle thing that goes on here called deferred execution that you need to know about. That's it. Any questions? Any questions? Over here. Yes. So the question was, what's the difference between toList versus toArray? The question was, why would you use toList versus toArray? And the answer, I've already said, I tend not to use arrays at all, but if you actually have to return an array, then you would use toArray. But I generally always use toList because I'm trying to get away from having to use arrays in this world today. So that's the answer. If you've got further questions, go ahead and come on up. I've got a book. You forgot. So here's the question. Something you learned in my call to action in the first 15 slides. What was this? What was that? Use anonymous methods generally. You read my book. Go ahead, yeah. Thanks a lot.